All right. Well, so let's see. So our mission is to try and refactor the multiway system code.
Right.
So let's pull up the code. Where is it? Code development function repository, multiway system. All right, I think what I want to do before we even get started is actually what I should do is to copy this. Hold on, let me just do that. Yeah, I'm just making a copy -old. Okay, all right. So what we were doing previously was, what's happening here? I thought I was just evaluating. Yeah, there we go. Okay, what I thought I was doing previously was making that list of, in Working Material 2019, is making the list of the API, basically. All right. So what I think we should do here is, in the end, we should be able to say multiway system of, and then we should be able to give an association that contains all these various pieces, like state evolution function, etc. Does that make sense?
Right.
Yeah, okay.
Right.
Okay, so let's do design here. So state evolution function, arrow, whatever it is, and right, so I think what we should do is maybe leave the things that involve just strings here, but define a general case which we can then, because for many initial, for many things like the sequential cellular automaton, we will know what the, okay, so state union function. And we've also got, I don't know whether state equivalence function is important for us. We'll find out.
Well, hang on. The state union function is just union with state test with same test going to state equivalence function. Am I correct?
Yes, you are correct.
So I think state. Sorry.
Go ahead.
I was going to say, so I think state equivalence function is what we want to specify. The union function we construct.
Okay. Okay, so then we've got state event function. Okay, so now include step number.
That does bring up an interesting case where we have effectively incompatibility between the evolution function and the event function, doesn't it?
What do you mean by incompatibility?
That to check that we're not doing something weird, we have to confirm that the set of states produced by the state evolution function is generated by the set of events produced by the state event function. I'm just,
if we do something weird, we do something weird. I mean,
I'm just checking that I've understood the distinction correctly, right?
Yes,
okay.
you're correct. I mean,
okay.
I think that the okay, so I reckon what we want to do here, we're going to have all states list unmerged. Okay, so let's write down the general case, okay?
Okay.
which is multiway function, multiway system of, and then I reckon it's this. Oh gosh, we have to have, how do you do that with an association to have pieces that could be missing? I don't know how to do that. I think there is a way to do that.
By the way, I'm just wondering if it's worth creating this function with a different name first to check that we reproduce the existing multiway system for the string case.
It's going to be easy to check because we're just going to feed strings into the first argument.
Okay, fine.
Okay, so now let's just do an init and an n blank integer. Okay, so now this case, the case of all states list unmerged, all states list unmerged, is purely, why is that turning in all? I don't know why it's looking like that, but anyway, okay. And then this is simply, I reckon, nest list of evolfun, comma, init, comma, n, I think. So I'm going to start accumulating in a different file the examples. So this is general case examples. So then here, I reckon, let's say we have evolfun is string replace list there's an argument. I see. Okay, fine. I mean, okay. So then this one goes string replace list of hash, comma, let's say A goes to AA or something. That's our rule. Flatten of that. And our state equivalence function is just the same queue. And our state event function we haven't defined yet. And our initial condition can be just A. And our N is 3, let's say.
The state event function, can't we reproduce that with string cases?
I think we can, but why didn't that work? Didn't I just define this? Doesn't that association match? Oh, silly me. Okay.
Well, hey.
All right, string cases. So state event function. Well, remember, okay, the format of the state event function is supposed to be, okay, let me just do multiway systems dash. Okay, the format of the state event function is going to be rule prefix suffix. Okay.
Right.
Okay, so for strings, I think we have to look down here at what we actually did. This keeps track of predecessors here. Aye, 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 aye. Predecessor rules list. Well, let's go on to the next thing. That's all states list unmerged. So the next case is the default case where things are merged, right? Well, you got to go down.
Right.
So let's go down here. I don't know whether I can keep those over there. Oh, what a mess. Let's do the really silly thing here. Just take those. Okay, all states list, which is otherwise known as the default.
Right. Which is just map of union. Correct.
Oh, it's not map of union, it's the union at each stage.
But aren't the stages just in a list here?
Right, but where is...
So surely we're just mapping over that list. Unless I've missed something.
Hold on. Generated, where is the actual default evolution? Oh, there. Union
to the top there.
Yeah, right. Okay, so then this is... So now we want this, and now this one is all states list. And I claim that for each evolve function, yeah, that's the step there. So for each evolve function, it's doing a union that's the function, right? So it's doing a union of that with same test, arrow,
Equivalent.
Okay, let's try this now. Looks reasonable enough. Looks fine.
Hey.
Okay. Now, we might as well, while we're at it, deal with the subcases of that. Okay, in which we get rid of the n. Well, we could deal with the subcases, but remember what we're going to do in the end. Each one of these, okay, so eventually we're going to have a thing that says sequential cellular automaton or whatever else it is in here, and we're just going to turn it into something with the appropriate evolve funds and so on.
Mm-hmm.
Okay. All right, let's keep going then. States count list, that one is trivial. Well, not so trivial. What's this doing? I see. That's the whole point of that, is it's just throwing the length. It's not doing, you know what I'm saying?
Right. It's not actually doing the evolution.
Right. You know, I have half a mind to keep this in a separate place. Let's do that. Let's keep these separately, and then we're going to merge them at the end, so to speak.
I agree.
Okay. So let's put these. Okay, so now let's do, let's call this basic evolution. Now, okay, this is the counting case. Okay, so here, that step becomes union of evolve fun. It becomes this, doesn't it?
Right.
That's uninspiring. Why did that not work? Oh, because I forgot a comma there. That's not right. Okay, this here, union of evolve fun of that. Oh, I think I don't want that there. Yep, that's fine. Okay. All right, keeping track of predecessors. Okay, what the heck is this doing? Multiway. What is that doing? Oh, I see. That's giving
The predecessor state for each state of the multiway level.
Yeah. Okay, so what's the analogous thing? What's the way to do that now? And then what?
In effect, this requires breaking, at least if you've written it here, it requires breaking the state evolution function into pieces, right? The flatten is separate from the string replace list.
Ugh.
So maybe we need two things. We need like an evolution function and a kind of post-processing step, so to speak.
Yes. All right. Well, let's see what this is going to do now eventually. So this is going to give, okay, so that's ultimately going to give a states graph. Fine, then we feed it into this here.
Right.
Okay, all right, so then what we want, so what is that? So we want the individual evolution step, right?
Right. I think it still makes sense to call that evolution function.
Or successor function, state successor
The
function.
successor function is perhaps nicer, yes. And then there's like I don't know what we call it, a collection function or post-processing function or something.
And it isn't always just flatten. Why do we need that? I think what we need is the state evolution function should not contain the flatten.
Okay, I wasn't completely confident that it would always be flattened, so to speak.
I think it will be.
Okay.
All right, so then here, we need to say flatten. Okay, so then the definition here, I think we should call it state successor function. Well, okay, so state evolution function, let's actually put that in.
Wait. Flattens at every level, right?
Yes, that could be disastrous.
So for hypergraphs, that's completely wrong.
Yeah, so it just says flatten, 1 here.
Right.
Actually, can't we just use catenate here instead?
That's what I'm doing for the Wolfram model case, yeah.
Okay, hold on. Okay, so let's just make this table here. State evolution function, the list of successors for a given state. Okay. State equivalence function. Whether two states should be considered equivalent. And state event function. What's the relationship between the successors and the events? Don't we need to have those correlated?
Yes. Also, I'm not entirely sure that catenate is right either. I think actually in the Wolfram model case, we don't need any post-processing function.
Why?
Well, at least the way that I've written the evolution function for Wolfram model, it shouldn't require any of that. And hang on.
But look. This is the successors for a given state.
Right. But hang on. Let me send you something. Am I going crazy, or is this wrong? Or should those be wrapped in an additional? Wait, hang on. Sorry.
Catenate takes.
No. Okay. Right. We're okay.
I think we're okay for yeah. Okay. So hold on a second.
Fine.
But the state event function needs to be both the event and the successor, doesn't it?
Right. Which is why I was a little bit concerned earlier that we have to make sure the evolution function and the event function are somehow compatible, but they...
Well, I know, but why don't we have a combined function?
Oh, so you're thinking the evolution function is reconstructible from the event function?
Yes.
I agree, yeah.
The list of events for a given state. And okay, and then I think we want to have a combined event evolution function That's what I claim. Okay. All right, so let's take a look. Okay, so hold on. Let me just okay, so we don't want that flattened there. Okay, that's not good. Okay, so this is going to be nest list of union of catenate of evolve fun. That's again going to be a catenate of evolve fun. Okay, let's see what it does. Okay, dandy. What? Oh, that's because I had another flatten in there. Okay. We should probably do a non-deterministic Turing machine or something just to make sure that we know what we're doing here.
Right.
All right, let's do that actually. I think I actually had a non-deterministic Turing machine. Where is it? Function repository sources. Oh, I didn't have the non-deterministic Turing machine after all. Okay, but I do have the non-deterministic cellular automaton. So then here, let's take this case here, for example. Okay, so this would now be Oh, interesting. Okay, so that's for a single state. So that would be non-deterministic cellular automaton. And then it would be the rules, 170, 240, for example. Then it appears that that would be a list like that. Same queue is right. Then this would be 0, 0, 1, 0, 0, for example. Okay, what went wrong there? Okay, states are a list there.
Do you need an evolution time? No. No. Wait.
Okay, so let's take a look at what that does.
You should be applying that as an operator, correct? Not as a second argument.
It doesn't make any difference. It can do either.
No, but in the top case, it also requires a time evolution. If you want just one step, you need to apply it in operator form, unless there's something I'm not seeing.
Okay, all right, fine. Maybe I don't have to put that in a list. Is that right? Oh, I don't have to put that in a list because no, this is totally confused. Okay, so hold on. Let's look at what this is doing. So this is going to take what does this actually do? From each state, let's take a look at what this does. So let's imagine that's the state. I think the catenate of this, I think this needs to be in a list, doesn't it?
Right. Hey.
Hunky dory. Okay. All right. That's that case. All right. Fine. And the reason that's in a list, this is auto-flattening. Yeah, you know, the problem is this is not going to give us enough information. See what I'm saying? This is just doing.
It doesn't give event information.
Case. Yeah. This is effectively already doing the multiway system, so to speak.
Right. But that's a particular problem with non-deterministic CA. It's not a problem with our multiway system implementation.
No, I agree. So the CA case, Yeah, so the correct version of this is just to say okay, so that's the thing. It's this mapped over R, I claim. Mapped over 170, 240, for example. That wasn't successful. But so you understand what I'm trying to do here. This will be, it's this.
You need to flatten the rule list.
No, I got the right result there. This thing should be feeding. You know what? We may be doing the wrong thing here. This is wrong, I think. Because what this has to do okay, this is the successor of a single state. Yeah. We have to map over this, right? Because this isn't going to work. It's mapping this over this thing here.
Right.
So I think it's this /@ hash Hunkadorasaurus. Is it right? Well, that's a bit unfortunate. That's not right there.
Yeah, it looks more right than the other thing.
This thing looks more right, right?
Yeah.
So this may not be right here. Why has that got a 0 there? That's wrong. I don't see how it can get the 0. Okay, so that's
Wait, hang on. Cellular automaton rule 170 maps single black cell to 0.
No, it doesn't. It's a left shift.
Oh, yes. Okay, right. Because, okay, yes. But is it? No, never mind.
240 is a right shift.
Okay.
So this basically should just make a little walk. You know what I'm saying?
Right, which it does. So we're okay.
Yeah, but why is it giving this here? Well, there's something wrong with this code here. Okay, all right, let's keep going then. So now, the next thing we want to do is look at yeah, and by the way, we should get this one for Wolfram model as well, which should be comparatively easy, but let's worry about that in a minute. Okay. I mean, one of the issues here is that we really like this to say non-deterministic cellular automaton. Okay, let me understand something. What I'd like it to say at some point is, you know, multiway system of Wolfram model of blah, blah, blah.
Mm-hmm.
But it has to be a special version of Wolfram model because it's got to generate right. It's got to go inside the Wolfram model. I guess it can do that to generate all of the subcases, so to speak.
But that's what the code I have does. The thing in the email behind it, isn't that what this does? Is what it was meant to do, at least.
Fine. What's $subset?
That's just if I operated directly on vertices, the graph gets confused. As in, if I have vertices that are lists of lists, it doesn't like that. So $subset is just an inert flag that I then remove.
Okay. Well, let's actually write up here. Multiway system of non-deterministic cellular automaton of rules blank, comma, rest triple blank. All right, so we're going to be able to write, actually, let's see. Could we write one of these in terms of a substitution system? We could, couldn't we?
Mm-hmm.
That could just be a substitution system up there. Okay, so we'll do that in a minute as well. Okay, so the evolve fun for this is that, and the equiv fun is same queue, and the event fun is for now just XXX. Okay, let's do the one for a substitution system. And actually, that's cool because it will allow us to do lists and all kinds of things like that. Okay, so this says substitution system of rules. What the hell does this look like? That, okay, so let's look at that. So what we've got then So that's what it looks like. But the point is that a substitution system, this is kind of a hack, because the substitution system does a definite thing. You know what I'm saying? Really, what we should be calling this is the substitution system is just going to run like Wolfram model. It's going to run with the default updating order. You see what I'm saying?
Right. And I think the updating order is just apply left to right everything to get the next step, right?
Yes. But it's not obvious that we should use, insofar as we use this, we could also perfectly well use Cellular Automaton. Arguably, okay, so arguably what we should be doing here if I'm not mistaken, is that first case should instead be multi-way system of a list of cellular automata. You know, 240, etc. See what I'm saying?
Mm-hmm.
Because that yeah, I think that actually makes more sense. Because then, in a sense, we can do that with any of these things, right? A substitution system, I wonder what it does if you do substitution system of it seems to work just fine. Okay, I do think that makes more sense. Don't you agree? Because that way you're admitting that it is, so we could imagine something which is partly yeah, I think this is right.
Yeah, right.
Okay.
You give it a sort of all at once object and it converts it into a multi-way object.
Well, you give it a list of all at once objects.
Right, right. There isn't a Wolfram language function for sequential substitution systems, is there?
Not as such.
I guess there's replace.
Yeah. All right, so this is wrong. So let's replace this. That basically becomes blank blank cellular automaton. Actually, may not care what that is. It may be that it's just
It's anything that can be applied in operator form to something with a rule.
right. Okay, well, let's write out what this is, though. What is this? This is simply, yeah, I think it's just I think it's as simple as okay, so what we have got to do I think it's just this, right? Let's see what happens with that. Okay, so here, what happens here? State evolution function. What the hell's wrong with that? We hadn't reevaluate up here. Why did that not evaluate? State evolution function, that should be going to, oh, wait a minute. Do I not have the case? Oh, I forgot the case where there's no all states list.
Right, which it should just default to that.
Can I write it here with something with a pattern there? I think do I just say optional or something for that? Oh, no, but I need to. I think it's blank colon. Oh, no, that can't work. Well, okay, here I can clearly do it explicitly. This thing. It's kind of grotesque to have to write out the whole thing again. Okay, hunky-dory. Okay, let's do the same thing. Right, okay. let's do the same thing for a substitution system. Okay, so here, I actually believe it's exactly the same, isn't it?
Yeah, right. Which is why I think it's worth having a case for any function that can be applied in operator form to a given rule.
Yeah, I understand. But so let's look at the substitution system case here. Would be do we think that's correct? Let's try multiway system of okay, it's not correct. All right.
Yeah, there shouldn't be things of different lengths, for one thing.
Well, let's think about what it did here. Okay. So the single step here, let's apply that single step to the initial condition. Well, actually, to
What happens if you don't do it with strings, but you do the analogous thing with lists? Does it also fail?
I don't know, but let's just try this. Okay, so rules here is okay, let's apply that to, does it apply itself to just AA? No, it applies itself to list AA, I think. Does it apply itself to list AAB? I think so. Okay, what the heck is it doing there? Oh, look what it's doing. It's not a single replacement.
Right, it's doing all possible replacements in each step.
So substitution system just isn't the right thing. You know what? Maybe cellular automaton isn't the right thing either. Because we want, that's right, we want the thing to apply itself. That's why the other thing is full of tupelsism. You see what I'm saying?
Mm-hmm. Because we wanted to apply only in one place.
Yeah. Right.
Which is why I think it would be easier to do if we had a sequential substitution system function. Like we generated a sequential cellular automaton function. Because then we're just in effect, we're just changing the order relation of, to
I
change.
know. Right. So that is a except we don't really want it to be called sequential substitution. It's a okay, really.
Well, it's sequential where you define the sequence, really.
Yeah, I mean it's non-deterministic in the sense that it is yeah. Okay, hold on. Let's think about this for a second. What do we want to do here? You're right. It's like a sequential substitution system. But what did we do for sequential cellular automaton? Didn't we explicitly give?
Yeah, we gave a list of updates. So yeah, as I say, in effect, we're defining the sequence.
What's that? Oh, I see. That's where to apply it. Okay. So you're saying a sequential cellular automaton with a single argument should do what?
It should generate all possible. I mean, that should be like the evolution function.
No, but yeah, right, exactly. But the point here is I mean, what we really should do is to be feeding into these things gosh, how to do this. This seems non-trivial in terms of, I mean, because it requires unpacking all these things. So, I mean, a syntactic mechanism for here would be simply to say multiway system of quote cellular automaton arrow and then the rules. I mean, that would certainly be a cheap way to get out of this. And then substitution system arrow rules and so on.
Right.
Are we going to call it cellular automaton, or are we going to call it, I mean, we could call it, for the substitution system, I guess we just have to look and see whether it's string or list rules. So here, let's see, the string rules would have the form underscore string arrow underscore string that thing dot dot dot, right? Dot dot, actually. Okay, and then, oops, underscore list goes to underscore list is this other one, right? Okay, so now we have to write the state evolution function for each of these, right?
Mm-hmm.
So let's do the one for strings first. Okay, so the state evolution function for strings, I claim, is just a string replace list. Do you agree?
Yes.
Of hash, comma, rules, ampersand. Oops, we didn't call that rules. Okay. All right, for a list, what is it? Is it replace list? I think it might just be replace list. What do you think?
That sounds right, yeah.
Okay, let's get rid of these. Okay, let's do the cellular automaton case, which we just got rid of, so let's not get rid of that. So the cellular automaton case is that the state evolution function is mapping the cellular automaton rules. I think it may be exactly this. Do we believe that? Okay. So now here we would say multiway system, substitution system, arrow, encouraging. That looks promising. It's even quite elegant. All right, let's look at this. If we do this as list, okay, that's not encouraging. Is it effectively sequence replace list? Is that what it has to be? Do you see what I'm saying? Because replace list.
Replace list is an all at once thing. No, wait, is it? No. Let me remind myself what replace list does.
I think it has to be decorated with triple blanks on either side. So I think the only way to do this with replace list is to do a replace in which every rule has been decorated. Do you forget what I'm saying. By decorated, I mean it says X triple blank
Yep, right.
thing, comma. I don't know of an obviously more efficient way to do that. I'm sure one could do that by having a sequence cases. And we'll probably need to do a sequence cases later on. Right, so sequence cases, if we did sequence cases here, it would get each of the left-hand sides. For each left-hand side, we get sequence cases.
Mm-hmm.
Well, okay, just a minute. But we can, the El Cheapo way to do it would be to map over the list of rules to say with P rules or something equals, and then we're going to map over the list of rules. And that would be P rules there. Then we map over the list of rules with something that says join X double blank hash Y double blank arrow join X hash 2 Y, that whole thing we want to apply that to the list of rules, I claim. What do you think?
I don't know, let's try it.
Well, that was uninspiring. No. Okay, hold on. Let's take a look at what P rules actually is. Why did that join not evaluate? Oh, because it's got the XY. Sorry, that's my mistake. Okay, so those look right. So now we have to pick one of those and do a replace list with it. I don't understand. Oh, silly me, silly me, silly me. I mean, that's right, but now I don't know why this doesn't. So why didn't that work? Oh, maybe it will. Let's try it again. No, why did it do this then? And why did it encrust that in another layer of list? There's something wrong with those catenate things. But anyway, here, one problem is those should be triple blanks. Okay, so I think if I do this, the replace list will do the right thing. But now something went wrong with those outer catenations. Okay, so now that would be our list. Where was the catenate? Up here?
Yeah,
There should be another level of list. Am I not right? That is that this if I were running this over okay, what went wrong here? Okay, the replace list the evolve fun wait a minute. The evolve fun is a single state, isn't it? So if init is a list, this thing should always be mapped over slash, shouldn't it?
Right.
And then the result of that catenated. So now is that going to give the right answer for some of these other things? Okay, let's look at this. Mysteriously, that gave the same answer. I'm suspicious about that. Seemed to go okay. All right, let's try it with a single one of those. Let's get rid of the echo. Looks promising. Looks fairly convincing. Okay, now let's try the case of the cellular automaton again, where we thought we wrote the right thing there. Did we think we wrote the right thing there? Okay. funny. Okay. This should say Cellular Automaton. Oh, for God's sake. Okay, so then this, okay, let's look at what this is doing. It's probably, it's nesting one level too deep. It doesn't need that. It just needs the outer level, I claim. Promising. But now, is this really doing the right thing? Is this is making, at each step, this isn't doing the right thing. This is taking, and this is not wrong either, I think, because what this is doing is it's taking the whole thing as a gulp. Right, it's not doing it individually on every substring, is it? You see what I'm saying?
But taking the whole thing as a gulp is what we want from the evolution function.
I understand, but that means the pure cellular automaton function isn't enough. See what I'm saying?
Right, right. I think this is doing the right thing for what we wanted to do.
No, for what we said it was doing, but the cellular automaton function has got to go and look at every tuple separately. See what I'm saying?
Right. Okay.
So it's got to break the thing into tuples, into, I think that's what this thing is doing. I don't fully understand this thing. Okay, so this is wrong. So at a naive level, the way this would work, we have to pick up the neighborhood size, and we have to do a partition. You know what I'm saying? We got to do partition state, comma, 3, comma, 1. Then we've got to map this thing over that. So we've got to apply this to a particular position there. Apply CA rule at to a particular triple. Makes sense. Is that making sense to you?
Yes. Yep.
Okay. Okay. So let's keep going. The next thing we're trying to do See, is that going to work right? Yes, it is. Okay. But that could equally well be multi-way system of substitution system, arrow this guy, comma this, oh, come on. Okay, what did I do wrong here? Rules arrow rest, right? What did I do wrong? Okay, that's thing oh, it's because I misspelled substitution system. Okay, good. Now I just want to check one thing, which is that that still works in this case here, because I can imagine that that piece of code does something different. Brilliant. Okay, so we could do the Wolfram model kit. Let's go on and do the backflip one. Okay, so this is now the next case is oh, look at that. That's now irrelevant. Okay, so the next case is this case with the predecessors, right?
Right.
All right, let's hollow this puppy out and put. Okay, so here, all right, that's a weird special case. For the case where it's a pure string, we'll deal with that later. Okay. Note, need to handle cases where init is naked and not a list of states. Okay, well, we're going to deal with that later. Okay. So predecessor rules list. Oh my God, what's all of this? Okay, multiway system ruled step. What is that doing? So that's what we had evaluated down here. And that's giving us from.
For a given state, what's the list of predecessor states?
Yeah, and how are we getting that from this? From a list of states. What the hell is this? String replace list. Well, there's a minor chance that we could try putting in that we can try just replacing the string replace list with a Wolfram.
Right.
That slash rules with just a Wolfram. Okay, so let's try that. So this thing slash rules, there goes to Wolfram. And now this needs to get passed to Wolfram and state. Okay, so here it's going to be this giant puppy. All right, multi-way. Why is it doing the first slash at there? Why is it passing the state? Why is it saying that first? Do you understand why it has the first slash at there? Oh, I see why. I see why. It's because it's finding the thing, not its predecessor at each step.
Right.
All right, drum roll. Predecessor rules list. Okay, so let's take this thing. What does the 3 mean anyway in this case? What does the 3 mean?
I presume after 3 evolution steps.
Oh, I better evaluate this over here. Okay, so that would just be this. Okay, so that's what we're trying to do. It's the first 3 steps, getting all of those things. Okay, so let's see what we did wrong. So, rule step X, important difference. Okay. Somehow that didn't get applied to anything. The string replace list, maybe it just has an extra level of I think we need to do this. Ta-da!
Nice.
Amazing. What's that?
Nice.
Yeah.
I didn't expect that to work.
Okay, let's do this now. Let's check that this does something reasonable. Sploff. Okay, so there's some flattening that got done that shouldn't have been done. Ah, we're using thread. Okay, let's go back and understand what this was. See what that's doing? That's trying to thread across. Let's put in an echo there. Okay. So that's mapping thread across this, right?
Mm-hmm.
Okay, now in this case, what the hell? I see. What it's trying to do is it's trying to turn that into A goes to see here, those are the predecessors. I think. No, those are the successors. You see what it's doing here? You understand? Can you see?
I can understand the strings case, yes.
No, but look what it's, okay, so what it's trying to do, it's trying to make a transformation. All right, so up here.
Yeah, I understand it's trying to thread something, but without seeing the code, I can't understand why it's failing.
That flatten is wrong.
Why isn't that a catenate?
Well, it should be. Let's just see if that happens to work. Nope.
It's producing a different problem.
Yes. Okay, so thread this. We're trying to map thread across this, over this. What does thread do on that? Ah, okay, so what we want this to turn into is 0, 0 goes to that first 0 there.
Mm-hmm.
0, 1 goes to the second 0. So is there a way that we can say that? Oh. Threads over any head H that appears in args. So does that want to be list? No. What is this trying to do? This is trying to take each one of these, right? It's trying to, I think it's always got a single thing on the right-hand side.
Mm-hmm.
So we might be better off just okay, the evolve fun is going to produce a list. Right? And so the problem here is we're just using thread. What we want is that evolve fun list wants to map separately onto each of those. So we just have to put another layer of mapping into this, I think. Do you get what I'm saying?
Right.
Evolve fun is producing a list. Okay, so this okay, hold on. Evolve fun makes a list. So onto state. Oh gosh. Look, this thing is returning a list, and we just want that list. Yeah, it's just x arrow hash, that list, well, function x arrow hash slash at evolve fun ampersand for that. So I claim it's that. See if I'm right. Encouraging there. Ta-da. Well, looks superficially at least right. Wait a minute, or did I just do, oops, I did the wrong thing there. Okay. Yeah, looks like it's working. Okay, so this then should give us, this will give us keeping track of predecessors there. So this states graph should just work, I claim. And that exponential evolution tree makes no sense. That's essentially the multi-way system. No, that's nonsense. What do I mean by that? What do I mean? I think that's the unmerged version.
Right, that's the all states list unmerged thing.
Right. Okay. So this then goes in here. What are we doing here? So then this is, yeah, this has to be one of these. Including the init. Oh God, what's this thing here? Okay, so it's going to call predecessor rules list. Which we're probably going to feed one of these to. I'm very suspicious about that flatten stuff going on here. But maybe it's okay. Okay, so that is just feeding in. Okay, so that's states graph. So let's say we do this here. Well, it produced something. Oh, that's the old version. Okay.
Good to have a comparison. Hey.
What do you know? Okay, let's try this guy here. Okay. Splarf.
We have the same problem as before. Something isn't being mapped.
Yeah, I know. Okay. All right. Let's see what this thing returns. Yeah, I mean, that flatten is undoubtedly wrong. Let's just try changing that. Let's try randomly changing both of those to catenates.
That's looking good.
What's that?
That's not looking good.
Oh, okay. So let's try to understand what this is doing. So this is generating a predecessor rules list. So we already know what that looks like. Let's generate that for this case. Okay, so what do we now want to do with this list? So what we want to do, each level of that list, so all we care about so all we care about is the underlying relations, right? We don't care about the fact that this one goes to two different things. We're just trying to turn this into 0, 0, 1 goes to 0, 1 and 0, 0 and 0, 1, right?
Right. Which means I think we have to map a thread across that. not
I
just
don't
called
think it's a thread. I don't think it's a thread.
Okay.
I mean, we have to map something.
Okay, you want to do it as two.
Yeah, so the
maps.
first thing we do is a concatenate here. The first thing we do, because we don't care about the top level.
Right. Mm-hmm.
Okay, so let's make sure that's what we did here. Yes. Okay. Map thread of reverse. Okay, so for each of these,
yeah, we want two nested maps, I believe. One for the input, one for the output, and then reverse.
Right. No, the input is always a single thing. So let's take this guy as an example.
But we have to map over that whole list.
Oh yeah, but that's a trivial map.
Yep.
Okay, so for this one here, what we want to do is we want to say function of R, let's call it. I want to say first of hash. No, function of R. R goes to first of hash. Map that over hash and take the whole thing and map it over the list. So let's try that for %30. Oh my God. That did something very weird. What's all this here? Okay, let's look at this. Here we've got a bunch of lists of rules, right? So
right.
first hash. Oh, that needs to be last of hash. Okay, and then there's a concatenate that I want to put around the whole thing, I believe.
That looks right.
Okay, so now this wants to go into that wants to be a concatenate.
We want the reverse because it's predecessor states.
I already did the reverse. That's what I did.
Actually, oh, sorry. Oh, yeah, okay, sure.
Hunky-dory. Let's check that the other one still works. And it does. Okay, we're making definite progress. Hold on a second.
Sure. I'll be back in a couple of minutes.
Yeah, actually, I need to disappear for. I'll be back in like 10 minutes. Okay.
Okay. Yep. Sounds good.
Should we let's end this session and then we'll restart again in about 10 minutes.
Okay.
That makes sense. Or should we let's pick a time. Should we pick a time, let's say 10 minutes past the hour?
Okay, sounds good.
Okay. See you then. Okay. Bye.